This video is about determining the equation of a line given 2 points, and it's lesson 52 in your book. Now, before we've talked about determining the equation of a line when we're given the slope and the y-intercept. And we use slope-intercept form, that y equals mx plus b, and we just plug in our slope for m and our y-intercept for b. Now, we don't necessarily have to have the slope and the y-intercept. A line can be graphed if you know the slope and any other point on the line. So we can graph a line that way, and we can also write the equation of a line that way. So in this example, which needs to be in your notebook, we're using slope and a point to graph a line. Now we want to graph a line that has a slope of 4 and passes through the point 3, 5. Now what we have here is the slope, that's our m, and we also have a point on that line. Now the slope tells us where to go, but the point that we're given tells us where to start. So the first thing we're going to do is graph the point 3, 5. Now this is positive 3, so that's right. And this is positive 5, so that one is up. So we're going to go right 3 and up 5 from our origin here. So I'm going to move to the right 1, 2, 3, and up 1, 2, 3, 4, 5, and then I'm going to draw a point right there. Now my slope tells me where to go after that. So my slope, my m, is 4. And if I want to make it into a fraction, I can say it's 4 over 1, and that gives me my rise over run. So my rise is positive, so I'm going 4 up, and my run is 1 positive, so I'm going 1 right. So I'm starting at the point that I just graphed, that 3, 5, and I'm going 4 up and 1 right. So from here I'll go up 1, 2, 3, 4, and then to the right 1. Now I could also say that my slope was negative 4 over negative 1, because negative divided by a negative is still a positive 4. So I could say I'm going 4 down and left 1. And from that point I could go down 1, 2, 3, 4, and then to the left 1, and that would give me another point. After that I would just have to connect my dots. And there I have a line that has a slope of 4 and passes through the point 3, 5. In this next example, which needs to be in your notebook, we're going to use the slope and a point to graph again. Now we want to graph a line that has a slope of 0 and passes through the point 2, 3. So again, I'm going to start with the point that I'm given, which is 2, 3. Now this is positive 2, which tells me that I'm going to go to the right, and this is positive 3, which tells me that I'm going to go up. So in order to graph that point, I'll start at the origin and go right 2, 1, 2, and up 3, 1, 2, 3, and draw a point. Now that point is on my line. Now this says that I want to graph a line that has a slope of 0. So my rise over run, or my m, there we go, equals 0. Now in order to make that a fraction, I can just make it a 1. It really doesn't matter what number's down here, because 0 divided by anything is still going to be 0. So I'm going to rise 0, which means I'm going to go 0 up, and I'm going to run 1, and it's positive 1, so I'm going to go 1 unit to the right. So from my point that I graphed, I'm going to go up 0, which means I'm going to stay right here, and then I'm going to go 1 to the right and draw another point. Now all I have to do is connect those two dots, which creates a horizontal line. Now you should know from previous lessons that horizontal lines have a slope of 0, because they're not going uphill, they're not going downhill, they're staying flat. So a line that has a slope of 0 should be a horizontal line, and we've graphed that correctly. Now we're going to talk about a new form of a linear equation. Now the form you've always used up till now was y equals mx plus b, and that's called slope-intercept form. The reason that that's called slope-intercept form is because in order to create your equation of your line, you need the slope and the y-intercept, hence slope-intercept. This form is point-slope form, and it's called point-slope form because in order to create the equation of the line, we need a point on that line and the slope. Now, the point could be the y-intercept, or it could be any other point on that line. It doesn't really matter which one. So here's our point slope form. Y minus y1 equals m times x minus x1. M is still the slope, and x1, y1 is some point on the line. Now, it doesn't matter what point on the line. It doesn't have to be the y-intercept or the x-intercept. It just has to be some point on the line. This is definitely a formula that you're going to want to write down in your notes. Now we're going to use point slope form to write the equation of a line. This is an example that needs to be in your notebook. So we want to write the equation of a line that has a slope of 3 and passes through the point 2, 4. And we want to write this equation in point slope form. So let's rewrite point slope form. We've got y minus y1 equals m times x minus x1. This is our point slope form. In order to fill it in, we need our slope, we need a y value that's on the line, and then we need an x value that's on the line. Now we're given our slope, it's 3, so we know m is going to be 3. We're also given a point on our line. So x1, comma y1 is going to be that point, 2, comma 4. In order to create the point slope form of this equation, all we have to do is fill in our slope, our x1, and our y1. So I've got y minus, and then my y1 is 4, equals m, which I know is 3, times x minus x1, which is 2. So my point slope form of the equation of this line is y minus 4 equals 3 times x minus 2. Just like in slope-intercept form, you don't fill in the y and you don't fill in the x. All you need is the slope, the x1, and the y1. Here's another example that needs to be in your notebook. Here we want to write the equation of the line that passes through the points 1, negative 3, and 4, 5 in slope-intercept form. Now, we want slope-intercept form, which is y equals mx plus b. M is the slope, and b is the y-intercept. Notice that here we don't have the slope, and we don't have the y-intercept. We actually have 2 points, and neither one of them is the y-intercept. We would know they were the y-intercept if the x was 0. So we're actually going to use point slope form to finish this. Now, my point slope form is y minus y1 equals m times x minus x1. So in order to do this, I need the slope, and I need some point on the line. I know I already have 1 point on the line, but I can find the slope by using the slope formula. So remember, the slope formula is m equals y2 minus y1 over x2 minus x1. So I could call this x1, y1 here, and I could call this one x2, y2. And I could fill those numbers in here to get my slope, which is exactly what I'm going to do. So my y2 is 5, my y1 is negative 3, my x2 is 4, and my x1 is 1. Now 5 minus the negative 3, minus the negative is really plus, so it's like 5 plus 3. 4 minus 1 is 3. And then 5 plus 3 is 8. So my slope is 8 over 3. Now I have my slope, and I have 2 points on my line, so I can actually use either one. But I'm going to go ahead and use the first one to create my point slope form. So I've got y minus y1, which I already labeled as negative 3, equals m, which is 8/3, times x minus x1, which I said was 1. Now this is the equation of the line in point slope form, and that's great. But the question is asking for it in slope-intercept form. Now, we don't have to find the y-intercept and then plug it in here. We can actually simplify this equation by solving it for y and it will be in slope-intercept form. So that's what I'm going to do. I'm going to simplify this equation and then solve it for y to get slope-intercept form. I'll start over here. I know I have y minus a negative 3, and minus a negative is really plus. So I'm going to turn this into y plus 3. On the right side, I've got 8/3, and then in parentheses, x minus 1, which means I need to distribute. 8/3 times x would be 8/3 x. And 8/3 times negative 1 would be negative 8/3. Now, in order to get this into slope-intercept form, all I have to do is get y by itself. So since I'm adding 3 here, I'm going to subtract 3 from both sides. Those are going to cancel, and I've got y equals 8/3 x. This is negative 8/3 minus 9/3, so that would give me a negative 17 over 3. And here is my equation in slope-intercept form. And here's our final example about sales. This needs to be in your notebook, by the way. Rachel is selling seashells. She sold 1 for $5 and 2 for $8. What will Rachel charge for 5 seashells if she keeps selling the seashells at the same price rate? Okay, so this is kind of in disguise here, but they actually do give us 2 points. We know that how many shells you buy determines how much money you will pay. So our shells are our independent variable, or our x's, and our payment, or how our cost, is going to be our dependent variable, or our y values. So 1 shell for $5 would give us a point 1, 5, and 2 shells for $8 would give us the point 2, 8. Now, if we want to create the equation of a line here, we can use our slope formula first to find the slope. So y2 minus y1 over x2 minus x1. So I'm going to do this. I'm going to say x1, y1, x2, y2. All right, y2 is 8 minus y1, which is 5. x2 is 2 minus x1, which is 1. 8 minus 5 is 3, 2 minus 1 is 1, and that gives me a slope of 3. Now I'm going to plug this into my point slope form. Oops, y minus y1 equals m times x minus x1, and create the equation of my linear function here. So I've got y minus 5, which is y1, equals m, which is 3, times x minus x1, which is 1. Now I have an equation that fits this situation. So 1 shell for $5, 2 shells for $8, etc. Now I need to know, what will she charge for 5 seashells? Remember before that my number of seashells was my x value. So since I have 5 seashells in this case, I need to plug in 5 for x, and that's exactly what I'm going to do. I'm going to use this equation and plug in 5 for x. Y minus 5 equals 3, and then 5 minus 1. 5 minus 1 is 4, so over here I have 4. 3 times 4 is 12. And then to figure out what y, or my cost, is, all I have to do is add 5 to both sides. So y would equal $17.